Let us proceed to the next question. It is given that an ideal Brayton cycle operates between maximum and minimum temperature of T3 and T1 respectively. For constant values of T3 and T1, the pressure ratio for maximum work output is. So we have an ideal Brayton cycle operating between T3 and T1, where T3 is the maximum temperature and T1 is the minimum temperature. So it is given that T3 and T1 are constant, means they are fixed. So I have to find the pressure ratio for which we can have maximum work output. So in this question, first we need to find work output. Then we will find the pressure ratio for which we can get maximum work output. So let us understand the concept of Brayton cycle. So it consists of a compressor which takes some work input followed by a combustion chamber in which heat is added, then the working fluid is air. So air is taken at state 1, which I can say P1, T1. It is compressed in a compressor to state P2, T2. Then this air goes to combustion chamber where some heat is added at constant pressure. So we have a pressure P3 and temperature T3 at state 3 where heat is rejected. And in this case, we get some work output. In turbine, we get some work output. So some part of the work output from the turbine is used to drive the compressor, which I can write WC. So if we draw this cycle on a TS diagram, we have a TS diagram. And if we talk of the processes, so I have a process 1 to 2, that is, this is 1 to 2. So this process is isentropic compression. Similarly, process 2 to 3, it is heat addition at constant pressure. So this is constant pressure heat addition. Now process 3 to 4, this is an isentropic expansion. And process 4 to 1, a constant pressure heat rejection. So if I draw this process on a TS diagram, so this is process 1 to 2 represented by a straight line on a TS diagram. So process 3 to 4 will be a curve like this, and then process 3 to 4 is again a straight line, which is the turbine work, and then process 4 to 1 is a constant pressure process. So if I denote this, this is 1, this is 2, this is 3, this is 4. Remember, we are talking of ideal Brayton cycle. Ideal Brayton cycle means the working fluid in the air is an ideal gas. So first we will find the work output. The net work output is given by turbine work minus compressor work. Now turbine work is given by, this is Cp T3 minus T4. Similarly, compressor work is given by Cp T2 minus of T1. So we can see from the TS diagram. Now net work is given by Cp T3 minus of T4 minus of Cp T2 minus of T1. Now since air is an ideal gas, so I can write T2 by T1 is equal to P2 by P1 gamma minus 1 by gamma. Now here P2 by P1 is the pressure ratio Rp. Now since P2 is equal to P3 and P1 is equal to P4, so P3 by P4 is also Rp. Similarly, I can write T3 by T4 For process 3 to 4, P3 by P4, gamma minus 1 by gamma. So I can write T2 as T1 into Rp की power gamma minus 1 by gamma and T4 as T3 upon Rp की power gamma minus 1 by gamma. Now gamma is a constant, so I can write gamma minus 1 by gamma is equal to x. Let's say, now since gamma is constant, so x is also a constant. So I can write T2 is equal to T1 into Rp की power x. Similarly, I can write T4 is equal to T3 upon Rp की power x. Now, putting these values in this equation, so I can get W net is equal to Cp. This is T3, and I can write the value of T4 as T3, this value. Similarly, I can write the value of T2 as this value. So substituting these values, I will be getting T3. So T3 upon Rbx minus of Cp T1 into Rpx minus of T1. I can take this Cp T3 out. This is 1 minus Rp की power minus x, and this is Cp T1 Rp की power x minus of 1. And this is x. And this is Cp T1 Rp की power x minus 1. Now, see, these two are constants. These two are constants. X is constant. So the only variable is Rp, that is the pressure ratio. So if I differentiate this network with the pressure ratio, so this is constant. This goes to 0. This is d by drp of Rp की power minus x. This again a constant, and this is again d by d of Rp into Rp की power x minus of 0. So since this is constant, so this goes to 0. Now for this, I can use the simple differentiation formula d by dx of xn is equal to nxn minus 1. And this is a very general formula. So I can write dw net upon drp is equal to cpt3 minus of, this is minus x into Rp की power minus x minus 1. This is minus Cpt1. So this can be x into Rp की power x minus 1. So now we have to maximize this, and we know that for a function to maximize, we have to differentiate it and then put it equal to 0. So putting this equal to 0, we get Cpt3. So this minus minus got plus into x into Rp की power minus of x minus 1 is equal to, so if I take this term to the left hand side, putting this equal to 0, so I will be getting minus here. Similarly, I have minus already here. This is Cp into T1 x into Rp की power x minus 1. Now this minus minus get cancelled. This minus minus Cp get cancelled. X get cancelled. So we are left with T3 by T1 is equal to Rp की power x minus 1 upon Rp की power minus x minus 1. So I can rewrite this equation as T3 into T1 Rp की power x minus 1 minus of, since this is in denominator, so if I want to take this Rp to the numerator, so I have to subtract it in this way. This is minus of minus x minus 1. So I get T3 by T1 as Rp into 2x. Now I have to find pressure ratio. Now I have to find Rp, and this Rp is in power. So you understand this concept that if x square is equal to 4, then if I want to take under root, then what I will do, I'll do divide the power by 1 by 2. I will just reciprocate the power. So similarly, if I want to get Rp, and I have to reciprocate the power on both sides, means I'll be getting T3 by T1 is equal to 1 by 2x. So for x, I already have x is equal to gamma minus 1 by gamma. I can put that value. This is T3 by T1 is equal to 1 upon 2 gamma minus 1 by gamma. So this is the final pressure ratio. And from the given option, option C is the correct answer.